Hey guys, and welcome to another Tomonometry video. So in this video, we'll be looking at piecewise functions and limits, and this relates to what we talked about last video called the notion of a limit. So it's a bit of a continuation. So in the beginning, I just want to show you guys a reminder of what a piecewise function is. So it behaves just like a regular function, except we're allowed to have more than one within it. So as we can see here, I give you an example with 2, but this could have 3, 4, and as many as we want. And essentially, it's just telling us what that function will look like for different values of x, so for different domains. So over here, for x is less or equal to 0, so all of this side, we will have the graph being equal to x squared. So we can draw it just like that until x is less or equal to 0. And then this function tells us that for x is greater than 0, it's just going to be equal to x. So that looks a little something like this. So now we're given this different function f of x, which is equal to x plus 1 for all values of x less than 0, so this red function over here, and then x squared plus 2 for all values of x greater or equal to 0, which is this blue function over here. So what if we wanted to find something like f of 0? So we can't really use this one here because it's less than 0, it's not quite equal to it, but we can use this one because it's greater or equal to, as we see over here. So it's just a matter of plugging in 0 squared plus 2, which is just 2. Okay, simple enough. However, what if we wanted to find the value of this f of x as x gets really close to 0 from the negative side? So what happens right here? So obviously, we can just see this. It would be equal to 1, right? But what if we weren't given these points? What if we weren't given the graph? What could we do? So obviously, plugging in f of 0 wouldn't work, and plugging in something close to 0 from the negative side is not really accurate. Like, what if we do negative 0.01? Well, this isn't really going to give us anything. It's going to give us something close to 1, but not quite it. So we can find exactly 1 with a limiting process. So let's take the limit as x approaches 0, but just a little smaller. And we're going to denote that with a little minus over by the 0 of our function that we're using, which is x plus 1 over here, because it's just a little smaller than 0. And what this allows us to do is just plug in this 0 minus over here. So this will be just something like 0 minus plus 1. And 0 minus is basically just 0, because we're thinking about a value of x that is really close to 0 from the negative side. So we can basically just interpret that as 0, which is just 1. And we got the answer we wanted. It makes sense. From the left side, this value approaches, this function approaches 1. But now what if we wanted to look at the value of this function as x is really close to 0, but just a little bit bigger? So essentially just to see what happens right here. So we can take basically the exact same thing, which is just the limit as x approaches 0, except this time it's just a little bit bigger, so I'm going to denote that with a plus, of x squared plus 2. We can just interpret this as 0 plus squared plus 2. However, remember what we said before with the 0 minus. This is just a value that's really close to 0, just a little bit bigger. So we can just interpret this as 0. 0 squared is 0 plus 2 is 2, which is coincidentally what we got over here. But remember, it's just because we're plugging in 0 into the same function. So for this example, I want you to try it by yourself. So we have f of x, which is denoted as x squared for x is less than 2, and 3x minus 1 for x is greater or equal to 2. So here we have x squared and 3x minus 1. So I want you to try to find the limit as x approaches 2 from the right and the left-hand side. You can try this by yourself. So let's get started. So here we have the limit as x approaches 2, but just a little bit smaller of our f of x. So without looking at the graph, how can we work on this? Well, we need to look at f of x for x is just smaller than 2. So looking at this, well, we can't use this one because 3x minus 1 happens when it's bigger or equal to 2, and we want just a little bit smaller. So we're going to have to use this value right here. So this is basically just equal to saying the limit as x approaches 2 minus of x squared, which is then just equal to 2 minus squared. And as we saw earlier, this is basically just 2, so it's 4. However, what happens when we want to find the limit as x approaches 2, but just a little bit bigger of f of x? So we can't use x squared anymore and plug in 2 there because we're trying to find the value of x that's just a little bit bigger than 2. And x squared only applies when x is smaller than 2. So we're going to have to use 3x minus 1 because it works for x is greater or equal to 2. So this is basically the same as saying the limit as x approaches 2 plus of 3x minus 1. And as we saw, we can just plug in 2 here. So 3 times 2 plus minus 1. And well, 3 times 2 plus is just 3 times 2. So 6 minus 1 is 5. So that's it, guys. Thank you guys so much for watching. I'll meet you in the next video where we'll look at limits and how to analyze them algebraically.